All right, picking up right where we left off here. For methods of assessment, I've already talked a little bit about those in a previous presentation, but I just want to highlight a few things here because we get into some more specifics about this. And I'm going to scroll on down here, and we don't really need to worry too much about either one of these. This is not going to be in your wheelhouse ever. So we're going to breeze past that, but let's go ahead and look at some of the methods that you'll have. And you'll have a client who will come in and say, I had a freebie evaluation for hydrostatic weighing, or I had a freebie for a bioelectrical impedance from somebody else, or a DEXA scan. That will definitely happen. And they'll ask you to interpret the results, or you'll have to do your own clinical results on site right there with the person. But it's good because you have this tool in front of you, this another evaluation tool that you can use from a third party to help you paint a clearer picture for your client. If we look at this, and I don't want to spend too much time because we're not going to get into it in this class, but when you look at like hydrodensometry, it's hydrostatic weighing essentially, where you then are talking about displacement of water. And with underwater weighing itself, you look at this. I'm going to use the side-by-side example here of these two gentlemen. You can see the different body types in terms of how much water they displace. You have a measure in terms of Jack versus Dave, how much they weigh underwater, because one is more dense because he has more muscle and the other has more fat, so he's more buoyant. And that's really what this comes down to. Residual volume, just in case you're ever asked this anywhere else, it's the amount of air that you still have left in your lungs after you've tried to exhale as much air out as possible. We have anatomical dead space within the system that will still hold some air. We still have some air that'll be held within the alveoli. And then also the GI itself will have some air in it. So we can't really get rid of all the air in the system, but you look at it in terms of statistical norms, you have just about the same for everybody. It's pretty darn close. The upside with this is, very accurate, which is great. Like anything, the more you practice, the better. Your big hangup is if they don't blow out all the air, that will be a challenge. And then the person has to sit still for a certain amount of time underwater, and they just have to be comfortable doing that. If they don't like water, then you got a problem. Bioelectrical impedance will probably be the predominant way you evaluate body composition, usually done through a Titana scale or a in-body type of system where you stand on a plate and it's a scale as well as it sends an electrical impulse through the body and you're holding handles, or you'll have the handheld, I always jokingly call it like the Batman steering wheel. But really what you have is, for all of those, the concept is you have a insulator in the body and you have a conductor in the body. You look at fat weight versus fat-free weight, kind of gets back to our two-compartment model, and you look at this electrical current, and the electrical current is sent through the body, and the bioelectrical impedance equipment, whichever one you're using, measures how quickly that electrical signal goes zap, zap through the body, and that's how it measures body composition. So it's a very small charge. You're not going to zap your people. I always describe it as, look, it's a very low level electrical current. You're never going to feel it, but it's just measuring how quickly it goes through the system. And then from there, this handheld or standing scale can then evaluate what your body composition is. And usually you'll be asked how. And that's done through a whole series of computations that are done by the computer, either on the handheld or what you're standing on. But it really comes down to how quickly that electrical current can go through the body. And the other concept that you have is, especially with the handheld, and people can kind of visualize this, we have a very high correlation between our height as well as our arm span. So the handheld one especially, or the ones where you hold onto the electrical, whether it's the in-body and you're standing and holding the handheld handles, or you're holding the handheld out in front, you have a correlation between your height and your arm span. So that's why part of the input is how tall are you, because it takes into account this cylindrical concept, like your body's a series of cylinders stacked on top of one another, and it's measuring how quickly that impulse goes up and back down, or in one hand, around and back down. And so that with that correlation of your height, whether it's to this process, meaning the length of a leg, or from one hand across the body to the other, we know from statistics there's a pretty high degree of predictability in terms of how long that distance is, and so then it can, with a high degree of confidence, measure how quickly that impulse goes across from one side to the other and be able to come up with body composition. That's really what it boils down to. Costs, many of the handheld ones are much less than this. Like the Tatana scales that you'll see in people's bathrooms are less than that, and they're pretty darn accurate. What's great is these are non-invasive, real easy as long as you can program everything in pretty quickly. The big thing with precision and accuracy is it comes down to how you do it and when you do it. So if you're going to do an intake with a person at 6 a.m., you know they haven't had a lot of water, they haven't had a lot of food, they're not really warmed up per se. Make sure you do any other body composition evaluations at 6 a.m. Conversely, if somebody comes in at 5 o'clock at night after work and they've had a full day of food, full day of water, make sure you do your next body composition at 5 o'clock at night, because that will then increase the validity of your testing from testing session to testing session over time. If you go 6 o'clock in the morning, 5 o'clock at night, 12 o'clock in the afternoon, forget it. It's going to be all over the place, and you're going to have too much variability just in the actual validity of a test to be even, too much variability in the test to even say it's valid. So you have to make sure you do it consistently at the same times. So we'll go ahead and just go through this. I've already explained this in terms of how it measures that impulse up and across the legs or across the arms. I'm going to take this down a little bit further. You know, you have to also have, in terms of hydration, just have your client, and I'm not too stressed about how much water they have, just as long as it's consistent. If it's consistent at 4 o'clock in the afternoon, great. And that's one of the big things, because, you know, they'll have the 2-compartment model. They'll give you fat weight, fat-free weight, and then the other printout you'll have is the water itself on the body. The assumptions, you know, I'm okay with this, and I don't think these are things you'll ever have to explain to your client, but, you know, understand that with this test, you're going to have people who will take this a month later, they're going to get a number that's the same or worse, and you're going to have to be able to explain to them in terms of just testing validity and make sure you do the same things all the time before you come in for the test. You've hydrated the same, you've had the same amount of food on board, etc. But I've had this happen many times in my career where the results are just not what one would expect. Dual energy x-ray, you'll have somebody who will come in, they'll say, look, I have this printout from my doctor, I did a dual energy x-ray. We won't have this in our class, I'm not going to stress you out with knowing too much about it on the DEXA, but, you know, you're looking at, as a tool, the 3 main areas it measures are bone, fat, and fat-free mass. And also there's a certain component where it measures the mineral content found in the bones, and it's very clinically based, and usually it's a doctor there doing the test, administering the test, and it's a very expensive test. So you won't ever really see this in terms of administering this in your fitness environments. But I'll leave it in here. I'll kind of scroll past it here so you can kind of get an idea of what it is. We jokingly call this the body egg, but you know, you have, much like water displacement, you have an air displacement concept where you have the inside of this chamber, a person sits in the chamber, and from there it's able to determine the air displacement and come up with a body composition number. It has its place, it's okay. Again, for what we do in terms of fitness professionals, you will almost certainly be doing body composition via bioelectrical impedance. And again, you may have somebody who will come in, they'll end up stating they had a test done, and they'll hand you a sheet and it'll be this test. You just have to be able to interpret it. So it's okay, but it's costly, and it's something that you're probably not going to get into as a practitioner. Same thing with near infrared. I'll leave it in here because you might have a client who will come in and speak to that, and you have to be able to have a conversation regarding a test that they've done. But what's interesting is, you know, all of these are working down the same path. They're going down the same path towards trying to figure out what is the person's body that is sitting in front of you? What is it made of? How is it composed? How much fat does a person carry around? And to some degree, you go from these very complicated, highly technical tools to the handheld, which is a lesser degree of complexity, or standing on a Tatana scale or on an in-body scale. And then you get to skin fold assessment, which is like the gold standard, right next door to the other gold standard, which is hydrostatic weighing. And if you're proficient at doing this and you've done enough skin fold assessments, you can be highly accurate in performing these tests. And it really comes down to knowing how to grab, where to grab, and by how, I mean how much. And for some people who come in, you might have somebody who's like a 500-pound person who wants to lose weight with you. A skin fold might not even be the proper thing to do with them because it's just unrealistic to get an accurate measurement. And so you may have to make some judgments in terms of how you do this. And for some people, it's a little too invasive. You have to pull the shirt up, you have to measure here, you might have to get here, who wants to be at the fold of the glute? So you're going to have some clients who might push back on doing skin fold. And some medically based wellness facilities want this as a measure. And I can tell you most fitness facilities will probably have skin fold calipers in their fitness office, but usually it's the handheld bioelectrical impedance that most people use just out of ease and just out of being able to administer the test quite easily. In a clinical setting, in a classroom setting, if you go on to another school and go to a 4-year, you no doubt will be doing skin fold caliper testing, and you'll be practicing this, and you'll grab the fat, pinch, 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 and you measure in terms of the caliper itself, what the caliper reading is, and you use that in a calculation to determine what the person's body fatness or body composition is. Now, you have some presumptions here, like you're presuming that most of or about greater than 50% of the fat is subcutaneous. We know part of it's going to be visceral. That's part of the deal. And you can't really measure at all visceral fat with calipers. So that kind of takes that off the table, whereas bioelectrical impedance will measure total body fatness. And same thing with some of those other tests. Now, the biggie is just the inability to perform a test correctly over and over and over again. But what ends up happening is the more you practice, the better you get. Now, I will state this. As a practitioner, I have done on the order of maybe 20-1 bioelectrical impedance to skin fold over the years. And it's just because of all the factors I mentioned before. You have a population of people who would much rather not be poked and prodded. They don't want to feel like they're in a clinical environment. They'd rather just have the quick and dirty numbers, and they're already there and they know they're overweight. You don't need to really grab and fold and use calipers on them to show them that they're overweight. And the other part of it is the invasiveness of it, like I mentioned earlier. So in some regard, you've seen in the industry-wide, people have kind of moved away from skin fold and they've gone more to bioelectrical impedance. And with individuals who can now wear a wearable and be able to get different data points, though not as accurate, but still have some data points right there on their wrist in terms of just their overall health condition, that has really moved us from the clinical analog side of skin fold thickness to more of the digital side of bioelectrical impedance. All right, guys, have a good one. Signing off.